All right, so for today, I'm going to be working questions 12 through 15. We're going to be looking at the measurement of sides and angles inside a parallelogram. We talked about angles before. We talked about this last week, but one of the things that I'm going to be looking at, let me take a look at the angles in the center. I see there's one angle that's already 60. So I'm going to say this other angle on this other side is going to be 60, right? Because remember how vertical angle theorem, when there's an X form, opposite angles are equal to each other. So I'm going to say if one angle was 60, the opposite angle is 60. I'm also going to say this angle right here is 120. The reason why I said that is because I see a line segment here. These two angles combined have to make 180. So if one of them was 60 already, well, the other one has to be 120. Consequently, I'm going to say this angle right here, it is 120 as well. Interesting though. Interesting is that if I add all three angles, just to double check, if I add all four angles in the inside, they should add up to 360 because it completes a circle. In this case, they do. I'm not gonna check it, but that's one thing that we can always double check. Okay, so I have some angles there. Now, another thing I'm going to check is given a triangle. So let me focus on a triangle here. Let me show you guys the triangle I'm looking at. I'm looking at this triangle. Given a triangle, if I know two angles, I can find the third angle, right? I see 120 and 34. I know two angles. If I was to add those two angles, 120 plus 34 is 154. Notice I added the two angles given. Subtract that from 180. That gives me 26. So I'm going to say this angle here, it is 26. Interesting though is that this triangle reflects on the other side. It's just that my angles are going to be kind of catty corner. I'm not going to go directly straight down. I'm going to say this angle here it is 34 and this angle here it is 26. They're going to reflect. Another triangle I'm going to be looking at now. Let me erase this triangle. Now let me focus on this other triangle here. I know two angles, 60 and 54. From this triangle, I know two angles, 60 and 54. If I add those two angles, 60 plus 54 is 114. Subtract that from 180, that gives me 66. So I'm going to say this angle here is 66. Interesting is that these angles are going to repeat on the other side. This triangle is going to repeat. I'm going to say this angle here is 66 and this angle here is 54. Another thing I want to emphasize here. Look at these two angles, 34 and 66. They repeat here. It's just the numbers are flipped, 34 and 66. Interesting part is that these two angles here as well, 54 and 26, they repeat on this other side. It's just that they are flipped. That's something pretty cool that happens in parallelograms. Okay, so I have all the angles that I need. Let's see. My first question here it is the measurement of angle L and K. So if I was to connect the points L and then N and then K, so if I was to connect those 3 points in that order, L, N, K, I get this corner. Well, that is 66 degrees. I don't have to write the degree symbol. I'm just going to write 66. Now let's take a look at the measurement of angle MON. So I'm going to connect the letters in that order. Starting at M, go to O, and then N. So MON. That gives me that corner there, which I'm going to call 120. For the next one, MKL. So I'm going to connect them in that order. Starting at M, go to K, and then L. MKL, that gives me that corner, and I see that's 26 degrees. And then lastly, the corner, the measurement of angle MNL. So I'm gonna go MNL, and that gives me 34. Pretty cool. Let's try this again. Let's take a look at question number 13. So to begin with, this numbers 13 and 9, I don't see a degree symbol. Those are measurement of sides. So those are not angles, okay? I'm going to be dealing with sides in this one. I didn't deal with sides in number 12, but here I'm going to be dealing with sides. Now, first, let's take a look at the angles. I see a 50-degree there. Right here in the center, I see that's 50. So that's going to say this is 50. And then consequently, I'm going to say this angle right here, it is 130, because remember, these two angles have to add up to 180. So that gives me 130, and then I get 130 here as well. I'm looking at a triangle. I'm looking at this triangle here. Two angles are given, 130 and 30. If I add those two angles, 130 plus 30 is 160. So I add the two angles given, subtract it from 180. 180 minus 160 is 20. So I'm going to say this angle here is 20. Interesting is that I know that triangle at the bottom as well. This angle here is going to be 20, and this angle here is going to be 30. Remember how my angles flipped. Okay. Now I'm going to be looking at another triangle. Let's focus on this triangle. I'm given two angles, 50 and 44. I'm always looking for triangles where I have two angles given. That's really what I'm looking for. I have two angles given here, 50 and 44. I know 50 plus 44 is 94. I subtract that from 180. 180 minus 94 is 86. So I'm going to say this third angle here is 86. And on the other triangle on the left, I'm going to say this angle here is 86, and this angle here is 44. The angles get flipped. Pretty cool. I have the measurement of all the angles that I need, so I'm going to be able to answer the questions about angles. The first angle that I see, the first question says the measurement of angle HJI. So let me connect the letters in that order. Starting at H, go to J, and then I. So H, J, I create this corner. That corner is 130 degrees. So the measurement of that angle is 130. I don't have to write that degree symbol, okay? So just the number. The next question is the measurement of angle GJH. So starting at G, go to J, and then H. Creates this corner, which is 50 degrees. Okay, not bad. Erase this right here. Next one, measurement of angle HFG. So starting at H, go to F, and then G. That creates this corner, which is 20 degrees. And lastly, when it comes to angles, HIG. So starting at H, go to I, and then G. That creates this corner, which is 30 degrees. Okay, angle-wise is not that hard. Now, let's take a look at the measurement of sides. Interesting is that my diagonals, when I mean diagonals, I'm talking about these two segments here in the center. Interesting part in parallelograms is that my diagonals cut each other in half. They don't have to be, both diagonals don't have to be the same length. They will be the same length if this was a rectangle, but because it's not necessarily a rectangle, then my two diagonals don't have to be equal to each other. They just cut each other in half. So having that said, let's change this to something that can be seen. Let's go with green, dark green. I see my diagonal GI. You see my diagonal GI? So from G to I. One part of my diagonal is 9. I can see the 9 here. I'm going to say the other part of my diagonal, so IJ, is also going to be 9. So remember, my diagonal gets cut in half. So if one half is 9, the other half is 9 as well. Now let me take a look at my other diagonal, FH. Half of diagonal, so here, this is 13. I see the 13 here. I'm going to say the segment JH is also 13 because one half is equal to the other half. Remember, my diagonals, they cut each other in half. That's what parallelograms do. So here, it's asking what's the measurement of the segment IJ? So from I, go to J. Okay, well, IJ is 9. So we're going to do 9. HJ. So from H, go to J. This case is 13. That's it. Remember that diagonals cut each other in half. They don't have to be, one diagonal doesn't have to be equal to the other. They don't have to be equal unless it is a rectangle. But in this case, it's not a rectangle, so we're good to go. All right, let's take a look at question number 14. Remember, I'm working up until 15. In the parallelogram PQRS, which we see the picture at the bottom, measurement of angle RTS is 107. Yeah, I see RTS is 107. Having that said, because that's 107, I'm gonna say, well, this other angle right here is 107. This angle right here is 73, because remember, these two have to add up to 180. And this corner right here is also 73. Boom, I already came out with some angles. The measurement of angle SPR is 84. I see SPR is 84. Interesting though is that, boom, I already have some triangle. I already have a triangle here. I have two angles, 84 and 73. Add them up, that's 157. If I subtract this from 180, that gives me 23. So boom, I already know this angle right here is 23. I'm just going with the information here. And interesting though, is that I'm gonna say, well, this is 84 and this is 23. If I continue reading, the measurement of angle QPR is 60. Oh yeah, I see QPR, connect Q with P and R, that gives me this angle, that's 60. Interesting is that I see a triangle there. I see that triangle, I know two angles, 60 and 107. If I add those two angles, it's 167. If I subtract that from 180, 180 minus 167 is 13. So I'm going to say this angle here is 13. Not only that, but at the bottom, I'm going to call this angle 13 and this angle 60. And then it tells me the measurement of the side PS is 5. Oh, cool. Let me go here with blue. So for the sides, I'm going to say PS is 5. Yep, I see this side is 5. Well, because it's a parallelogram, these are the measurements outside. So I'm going to say this is 5 as well, because opposite sides have to be equal. And then I have that the segment RT is 6. Okay, from R to T, RT, where's RT? Oh, okay, so here's a typo here. This is 6. I'm going to say this right here is 6, PT 6. Then ST is 4. So this is 4. Okay, we can correct that typo. ST is 4. So I'm going to say TQ is 4 as well. Now here is just going to ask me for one question. Find the measurement of angle SQR. Note, the diagram is not drawn to scale. So what I mean with that not drawn to scale is don't bring out your protractor and measure it with a protractor. They might be off. Just use the information given. Here I'm just asking, what's the measurement of angle SQR? So connect the corners, starting from S, go to Q, and then go to R. I'm going to use black for that. So here at S, go to Q, and then go to R. That gives me this corner, which I'm going to call 23 degrees. That's it. Okay. Lastly, I'm going to look at question number 15. Let me change this red for angles. In parallelogram ABCD, which is the one we see, angle BAC is 54 degrees. Boom, we see it there. Measurement of angle BEC is 67. Boom, I see it there. Measurement of angle DAC is 85. Yep, I see it there. Segment AD is 4. Yep, I see that there. Segment CE is 6. Oops, I have a typo here. And then BE is 5. Find the measurement of angle CDB, measurement of angle DEA, and a measurement of angle DBC. Okay, so I'm going to be looking for a few angles. So let me start from the center. I know this angle right here is 67, so I'm going to say this angle here is 67 as well. Now to complete 180, I'm going to call this angle 113 because I know these two angles combined is 180. So that gives me that this angle, this other angle here, it is 113. I look at the triangle on the top. I know two angles, 113 and 54. If I add my two angles, that gives me 167, right? I added my two numbers, 113 plus 54. Let me subtract this from 180. That gives me 13. So I'm going to say this angle here is 13. Funny thing is that this triangle gets reflected on the other side. So I'm going to call this 113 is there. I'm going to call this corner 13 and this corner here at 54. Remember, my numbers repeat. It's just that they get flipped. Don't forget that flipping part. Then I'm not going to use this triangle here because I only know one angle. Instead, I'm looking for a triangle where I know two angles, and I'm going to look at this triangle instead. I know two angles, 85 and 67. I'm going to add these numbers. That gives me what, 152. Right, 85 plus 67 gave me 152. Let me subtract this from 180. That gives me 28. So this angle here is 28. So I'm going to say on the other side, this is 28. This is 85. If I needed to know sides, because this side is 4, I'm going to say this side is 4. Because this side is 5, I'm going to say this other half is 5. Because this side is 6, I'm going to say this other half is 6 as well. Okay, let's see what I've been asked. The measurement of angle CDB. So starting at C, go to D. So starting at C, go to D, and then B. That gives me this corner, which I'm going to call 13 degrees. The measurement angle DEA. So DEA. That gives me this angle, which I'm going to call 67. And lastly, DBC. So connect D with B and C. So DBC, that gives me this corner, which I'm going to call 28. And there you go. That's what we did today.